Hello everyone, today's lesson is on Pythagoras theorem and trigonometry. Here I have a right angle triangle and I want to find the hypotenuse. The hypotenuse is the side opposite to the right angle. This is the AB. The Pythagoras theorem is the hypotenuse square equals base square plus the height square. In this case, the hypotenuse is the AB. The base is 9. The height is 14. And using this equation, we can easily find the side A and B. So this is the square root of 277. Rounded to one decimal place is 16.6 centimeters. In this exercise, we have three right angle triangles, and we want to find the side DP. Before finding the side DP, it is necessary to find missing sides and angles. We can find the AC, the hypotenuse of the right angle triangle CBA, by applying the Pythagoras theorem. So the equation is three square plus 4 square. This is 25. So the value of the CA is the square root of 25. This is 5. We can also find another side, the DA, because the DA is the hypotenuse of the right angle triangle DCA. By using exactly the Pythagoras theorem again, we can find the DA in the same way. (25 plus 4 is 29, so this is the square root of 29. And now what we're going to do to find the DP, we need to find the angles A1 and the A2. So I need to find the whole angle A, because the whole angle A is the opposite of the side DP, and then with trigonometry we can find the opposite side using trigonometric ratios. Let's summarize the trigonometric ratios here. We have a right angle triangle. We always have a reference an angle. So using the sine A, we take the opposite side divided by the hypotenuse. By using the cosine of the angle A, we take the adjacent side and we divide by the hypotenuse. And using the tan A, we take the opposite side and divide by the adjacent. So in this case, we need to find the total angle A, and the total angle A is the sum of the A1 and the A2. To find the A1, we use the right angle triangle CBA, and choosing the right trigonometric ratio, I'm going to use the tan of the angle A, because I have the opposite and the adjacent, and I want to find the angle. So by using the tan A1, then I create this equation. Taking the inverse function on the calculator, the inverse function can be found by pressing Shift together with the tan key. The calculator finds the angle for you. So this is the angle 36.9. We also need to find the angle A2 in a similar way. In this case, I choose the right angle triangle DCA, and again, I need to use the tan or the sine. Here I'm going to use the tan A2. The tan A2 is the opposite 2 over adjacent 5. Using the inverse function on the calculator, we can find the angle A2. This is 21.8. So the total angle A is the sum of the A1 plus the A2. So this is 58.7. And now what I'm going to do now is to use again trigonometric ratios to a different triangle than DPA and find the opposite side of the angle A. So I'm going to use again the sine function because I want to find the opposite, and I already have the hypotenuse of the right angle triangle. So I need to create the equation. So I'm going to use the triangle DPA and the trigonometric ratio sine A equals dP over root 29 and find now the dP side. So the sine of the angle A, 58.7, is equal to the dP over root 29, multiplying both sides by root 29, we can find the dP. So then dP is root 29 times sine 58.7. So this is 4.6 to 1 decimal place. This is the lesson for today. If you like the lesson, don't forget to subscribe to see more lessons like this one. Thank you for watching.